this will be a short one today. Today we're talking about the complement of a set. This word complement comes from the verb complete. Basically, the idea here is that this complement of a set will be the set that completes the set you are given. So A dash will be the complement of a set. This will be the set that, in a way, completes A. So it's going to be everything which is missing from A. So, I don't know if you've heard the expression, we complete each other. That would basically mean that they're complete opposites. One is this person, and this person is completely different, but we complete each other. So one is the complement of the other, using set theory terminology. But anyway, let's talk about a few terms here that we're going to be using. The universal set U. So we use U, which is the first letter of the word universal, to indicate this is everything we are going to be talking about in our problem. So, for example, if we say that we are looking at the digits that we write whole numbers with, well, obviously the numbers will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means the problem now is set. All the numbers we are going to be talking about in this problem are the numbers between 0 and 9, the whole numbers between 0 and 9, and that's it. So that would be our universal sets. And then we could say in this problem, we can define prime numbers and composite numbers. So we'll have these two sets. Prime numbers are 2, 3, 5, 7. Remember, for those who were about to say 1 is not a prime number, okay? So primes in this set would be 2, 3, 5, and 7. And composite, it means numbers which are not prime. So, for example, 4, 6, 8, and 9 in this case, because 4 is 2 times 2, 6 is 2 times 3, 8 is 2 times 4, and 9 is 3 times 9. Notice 0 is neither. I think we've mentioned this before. 0 is not prime, it's not composite, it's nothing. So the complement of a set is basically everything which is not in that set. Everything from your particular problem, right? 1 to 8, these are your numbers. If we take A to be the numbers 1, 3, 5, 7, and 8, then this A dash is everything which is not in A. Everything from this set which is not in A. So what is not in A? Well, 2, 4, and 6, because everything else is in A. So you see, basically 1, 3, 5, 7, and 8 is in A, which means that leaves the 2, the 4, and the 6 to go into the complement of A. So let's make some observations, which might seem a little bit confusing because we're using set notation here. This means that the intersection, so the common element of A and the complement of A, is the empty set. So what is that saying? It's saying that this set A and the set A dash have nothing in common, which makes sense because that's how we defined A dash. A dash is everything which is not in A, so we can't have common elements. So this notation here, please try to keep it in mind. You might get a question asking to rephrase something. They might give you something which looks like this, and they might say, oh, explain it, translate it into English. And you will have to say, for example, if this is students studying German, and this is students not studying German, you would say, well, there are not students who study German and do not study German at the same time. So you might be asked to interpret the meaning of an expression like this, so keep it in mind. The other thing we keep in mind here as well, to make a note of, is that the union of A and A dash is our universal set. It's everything. So notice here, if I take the union of A and A dash, which means to take everything together, like if I put these together, what do I get? I get 1, 2, 3, 4, 5, 6, 7, 8, and that is everything we had in this set. So the set U. So we say the union of A and its complement is equal to U. Another thing to keep in mind. And then finally, if you add the number of elements, remember this means number of elements inside that set. N stands for number. So number of elements in A plus number of elements in A dash, which means number of elements outside A. If you add these up, you get the number of elements in the original set, in the OG set. So here you've got 1, 2, 3, 4, 5 here. You see we've got N of A is equal to 5 in this case. And the number of elements in A dash in the complement of A is 3. Well, notice if we add the number of elements here, 5, to the number of elements here, 3, we get the number of elements in U, which is 8. If you add them all up, you get 8 here. If you count them, you've got 8. So that's what they are saying, provided that U is finite. So basically, all of these theories are nice and easy until we get to infinite sets, which have kind of a theory of their own. So don't worry about infinite sets. That's, yeah, it's a bit more challenging. So this is about finite sets. Just a couple of tricks I would like to make a note of, just for you guys to help yourselves. The trick I use is a translation of set notation into English. So what do I use? I use this note, I use this translation. This I translate into and. So the intersection I translate into and. The union I will translate into or. And the complement I will translate into outside. Whereas if I don't have a complement, I translate this into inside. So let me give you some examples about how I would translate, for example, down here. If we have A dash intersection B. So let me explain how I would translate that to just help myself. So A dash intersection B, I would translate this as outside A and inside B. So this is how I translate this notation to help myself. And when I say and, I mean at the same time. This is what and means in this context of set notation. Let me give you a few more examples. Let's say we've got the A dash union B. I would translate this as outside A or inside B. Let's say you've got A dash intersection B dash. I would translate this into outside A, one second, outside A, and at the same time, that would be outside B. So outside A and outside B. So a few things to help you here. This is pretty much what I wanted to say. Have a go at all of the questions, and I'll just give you some time to ask me questions after I stop the recording. So just give me a sec. I'll be stopping the recording. Yeah.